Alright, so the objective for this lesson is for you guys to know the difference between area and perimeter. We have talked a little bit about it, but we're going to write sentences about it today, which is going to be extremely fun. For those of you who like to write sentences in math. Not that there's very many of those. But just starting off, we're going to look at quadrilaterals, which is a closed four-sided shape. Now we're looking at only these four types of quadrilaterals. There are more, but we're not really concerned with those right now. We do talk a little bit about trapezoids in the posters and finding area and maybe perimeter, but we'll have the values there. So a parallelogram is a type of quadrilateral that has two sets of parallel lines. They're not all two sets are parallel to each other, otherwise they'd never close the shape in. All right. A rhombus is a quadrilateral where all the sides are congruent. Some of you guys prefer the word equal, and that's all right for now. Rectangles have four right angles. And then we have squares, which are a type of rectangle, which is also a rhombus. So it's a very specific type of rectangle or a very specific type of rhombus. It's not uncommon to see squares, so we do see them quite often, even though they are only a specific type of rectangle. So, if I ask you guys, are all squares rectangles?
No.
Yes, they are, because all squares have four right angles.
Squares are rectangles, but rectangles aren't squares.
So, it depends. So, are all rectangles squares? No, but can they be sometimes?
No.
Yes. If we cause a rectangle to have four equal congruent sides, then it becomes a square. So all squares are rectangles, but not necessarily all rectangles are squares. Sometimes. There is this Venn diagram here at the top, which shows that, right? So we got this circle, or this oval right here, which represents rectangles, and squares are also in there, but they're also circled by the rhombus oval. And all of these are inside of the quadrilateral. I guess that's the parallelogram square, actually. And these are all within the quadrilateral rectangle right here. Rectangle riddle number 1. Can you figure out the dimensions for each rectangle? Yes. Yes, we can. Use the clues below to draw the four different rectangles described. Rectangle A has a perimeter equal to that of rectangle B. By the way, it's important to read these before proceeding because sometimes we miss stuff. Rectangle A is a square. Rectangle B has an area of 24 square units. It is as close to a square as possible for that area if the side lengths were whole numbers, so no decimals. Rectangle C has a perimeter equal to the measure of the area of rectangle B. Rectangle C's length is 3 times the width. Rectangle D has two different odd integers as length and width. Each is 1 unit greater than the length and width of rectangle B. Alright, so here's what we're going to do, is I'm going to make a chart, and we're going to use that chart to figure out all the dimensions of it here. Alright, so these are my rectangles. And I'm going to make each column represent some kind of dimension from the rectangles. Length, width, perimeter, and area. Now, if we find the length and width of any of these, we can solve for the perimeter and area pretty quickly. But we can see from the first clue that A has a perimeter equal to that of B. So whatever the perimeter of B is, it will also be the same as A, the perimeter. So I'm just going to put a B there to remember that the perimeter of A is the same as rectangle B. It says that A is a square, which means that the length will also equal the width, because that is what makes squares unique, or a rhombus. The third clue says rectangle B has an area of 24 square units. Let's go ahead and fill that out right now. B has an area of 24 square units. It is as close to a square as possible for that area if the side lengths are whole numbers. So we got to look at 24 what two numbers multiplied together give us 24, because that's how we would find the area, right? That would make it as close to a square as possible. Yeah? So I can find two numbers that are even closer together, which would make it even more square-like.
6 times 4.
Yeah, I got 6 times 4. Those two are as close together as possible. So what that means is that for B, I have the length and width, 6 and 4. Just from that clue, it took a little work, but we were able to do it. And these are whole numbers. Now, rectangle C has a perimeter equal to the measure of area of rectangle B. Rectangle B had an area of 24, so C's perimeter also will be 24. Rectangle C's length is 3 times the width, so its length will be 3 of the widths. Now we'll get into that later. Rectangle D has two different odd integers as length and width, so this is going to be odd, and this will be an odd number for its length and width. Each is 1 unit greater than the length of and width of rectangle B. So that means it's going to be B plus 1 for both. And do we have the length and width of rectangle B?
Yes.
Sure we does. By the way, that means that the length and width of rectangle B would have to be even, and they are. So 6 plus 1 is 7, and 4 plus 1 is 5. All right, now that is all of the clues. Now let's go back to this 1, 2, 3, fourth clue, where it says that the length of rectangle C is 3 times the width. We already know the perimeter for rectangle C, which is 24. That's the perimeter. It was the same number value as the area of B. Now, as it turns out, this is perimeter, so we've got to take the length, which in this case is 3W. We got to add another W. Then I ran out of space. There we go. I got 3 W's, another 1 W, another 3 W's, and another 1 W. This gives me a total of 8 widths, which would have been the same as the perimeter, 24. So if I wanted to solve for the width, I would divide these by 8, and my width is 3 units. So if the width is 3 units, excuse me, what is the length of rectangle C? Yes? 9, because it's 3 of the widths. All right. So we're doing pretty good up in here. Can we find the perimeter of B?
Yeah.
How?
Just send it.
Yes?
Get high, get low.
All right, so B, the perimeter of B we would take the 6 plus the 4, length plus width, plus the length plus the width, and we would get 20 for the perimeter of rectangle B. This also means that the perimeter, wait a second, the perimeter of A also then would be 20 as well.
So then would the length and width be 6?
Not quite. Of B it is 6 and 4. But A, we need a perimeter where the length and width are the same, right?
How do you know it's 20?
So what we need is a perimeter of 20 for a square. So if the perimeter is 20, that's the same as if we were to use length on this. It'd be length plus length plus length plus length. Because there's 4 sides that are the same for a square. So this gives me 4 lengths is 20. And if I divide by 4, I can see that my length is going to equal 5. So the length of a rectangle A is 5, so the width must also be the same because it is a square. Now we have a few other empty boxes up in here. Do we know the area of A? Or can we find it?
Yeah.
Sure, how would we do it? 5 times 5 is 25. What about C? What would be the area of rectangle C?
That's a question.
All right, so the area of C is 9 times 3, which would be 27. The perimeter of D would be 7 plus 5 plus 7 plus 5, which would be 24 units. And to find the area of that one, we do 7 times 5, which is 35. All right, now that we have the length and width of all 4 of these, we should be able to go back and draw them. So let's start with A, which is a 5 by 5 square. So I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Bam, there's my square for A. B was a 6 by 4. So I got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Bam, there's a 6 by 4 rectangle, which we are calling B. C is 9 by 3. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9 by 3. There is C. And finally, D is a 7 by 5. So we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. There is D. Let's go ahead and label these. Bam, there it is. With the labels of the side lengths. Use words and models to explain the difference between perimeter and area. Let's use words first. So that's a good start for perimeter. It's the distance around the outside of an object. It's kind of the same thing as if you were trying to build a fence around an object. Okay. So it would be how much fencing do you need to fence in something, a house, property, children, whatever. All right. Area is the surface on the inside of an object. So how much surface do you have from fencing in the object? So, for example, if we were to look at perimeter, maybe some kind of shape like these. This one right here. I'm going to close it. That's a pentagon. Pent is 5 and a gon is shape. Or something like that. In any case, the red would be the fencing, and on the inside would be the area, right? So we would say there's all of the inside would be the area, and we make it colorful to make it pretty. Another thing we should notice about this is that the perimeter is one-dimensional while the area is two-dimensional. So this is kind of like that rock band, right? 2 dimensions. Or is it 1 dimension? Oh, is it? Oh, then it's not even dimensions. My bad. They sound the same.
Wait, so we don't have to write that?
No, you want to know that it's 1 dimensional and
What
2
if I did a
dimensional.
square?
Yeah.
Still 2 dimensional.
Yeah. So 1 dimensional means that if you had a perimeter of 5 meters, it's just meters. For 2 dimensions, it would be 5. We would say meters squared. So the 2 there, the exponent shows 2 dimensions, even though some people prefer to show it as square meters like this.
What is 2 dimensions?
It's kind of like saying, how tall are you? You wouldn't say 5 square meters because that's area. It's 2 dimensions. You could say you're 5, did I say meters? That's kind of tall. 5 feet would be the more appropriate answer. Now, if we asked you what the surface area of U is, you may say something like 10 square feet. I don't know. I don't know if that's about what it would be, but whatever. Can you figure out the dimensions for each rectangle? Yes. Yes, we can. Use the clues below to draw the 4 different rectangles described. The numeric measure of the area of rectangle 1 is twice the number representing the perimeter. Rectangle number 1 is 8 units wide. Rectangle 2 has the same number representing the area as the perimeter. The perimeter is 1/2 the perimeter of rectangle 1.
What?
I'm just reading the clues right here.
Yeah, but those don't make
Third clue, rectangle number 3 has the same length as rectangle 1. The area of rectangle 3 is equal to the difference between the areas of rectangles 1 and 2. Rectangle 4 has an area of 6 square units less than the area, so 6 square units less than the area of rectangle 3, and a width 2 units more than the width of rectangle 2. Alright, so to organize all this information, once again, we're going to place it into a table. So we have these 4 rectangles, and we want to figure out some of the dimensions for each of these. We have length, and width, and perimeter, and area, the same way I did on mine. Alright, the numeric measure of the area of rectangle 1 is twice the perimeter of, is twice the number representing the perimeter. So the area is, for rectangle 1 is twice the perimeter, whatever it is. We don't know the perimeter of rectangle 1 yet, but hopefully we will.
So why don't we just figure it out?
The number representing the perimeter of rectangle 1 is 8.
Just count the squares.
It says that the width of this thing is 8 units wide, though.
Wait, why this number?
Rectangle 2 has the same number representing the area and the perimeter. So the perimeter is the area is the perimeter. Just the number, not the units, because it's different. The perimeter is half the perimeter of rectangle 1. So we're going to take the perimeter from rectangle 1, number 1 perimeter, and we're going to cut it in half. Now we don't know the perimeter of rectangle 1 yet, but we will. Rectangle 3 has the same length as rectangle 1. So rectangle 3 has the length of number 1. We don't know what it is yet, though. The area of rectangle 3 is equal to the difference between the areas of rectangle 1 and 2. So we take rectangle 1 area and subtract rectangle 2 area, and that will be the area of rectangle 3. Rectangle 4 has an area of 6 units less than the area of rectangle 3. So area 4 is rectangle 3, but it's 6 square units less, so subtract 6. And the width is 2 units more than the width of rectangle 2. So this is the width of number 2, but it is 2 units more than that, so plus 2 more. Alright, I think we got all that information up in here. Alright, let's start with rectangle 1, because it has an actual value that we can consider on this. First of all, the perimeter of rectangle 1, actually the area. Let's look at the area of rectangle 1. The area is 2 times the perimeter.
Where are you writing?
Down here in the bottom. Well, how do we find area? Well, we would do length times the width, but we know the width is 8. Right account. Now the perimeter is length plus width plus length plus width. Alright, so I have length times 8 is the same as 2 of the length plus 8 plus length plus 8. I'm going to simplify what's in that set of parentheses. That would be 2 lengths plus 16 stuff. Now I'm going to distribute this 2, so I got 4 lengths plus 32.
That's 16 plus 6.
Alright, now we have a nice equation that we can solve by subtracting 4 lengths from both sides. And so I've got 4 lengths remaining, and that equals that 32 up in here. And so to find the length, I'm going to divide both sides by 4, and I see the length is 8. So this is 8, which is nice actually, because that makes rectangle 1 what type of shape?
A square.
It would be a square.
Really? I just guessed. Is it possible that
Alright, now that we have that, the perimeter is 4 of the length. Well, it's length plus width plus length plus width. But that would be 8 plus 8 plus 8 plus 8, which would be 32 units. The area is twice the perimeter. Is that true? Yes, it is. That'd be 8 times 8 is 64 units squared. So we have rectangle 1 taken care of.
How do you know this is?
All right, the area of, the perimeter of rectangle 2 is half the perimeter of rectangle 1. So we're going to take that 32 and cut it in half to get 16 units. And as it turns out, the area of this thing is also the same value as the perimeter. So that would be 16 units squared as well. All right, let's look at some other values we can fill in before we move forward. We can see that the length of number 3, rectangle 3, is also the same length as rectangle 1. So this also would be 8 units. Right here. And we know the area of rectangles 1 and 2. And the rectangle 3 has the same area as rectangle 1, 64, minus rectangle 2, 16. So rectangle 3 has 48 units squared as its area. The area of rectangle 4 is the area of rectangle 3, but minus 6. So 48 minus 6 is 42 units squared. All right, let's look at number 4. The width is the width of number 2, but then plus 2 more. But we don't know the width of number 2 yet, but we will. We will. Let's look at 3 because we do have a value right there. The area of number 3 is 48, and that would be the same as length, but we know the length is 8 times the width. So if I want the width of number 3, all I needed to do is divide both these by 8, and it tells me the width is 6 units. So this is 6 units. The perimeter is just taking the length and the width and adding it to itself again. So 8 plus 6 plus 8 plus 6 would give us 28 units. That's an 8 right there. So rectangle 2, we have an area of 16 units. And that is length times width. Yeah, so that's going to be length times the width. And the perimeter is also 16, which is length plus width plus length plus width. All right. As it turns out, 4 and 4 works on this. But, because 4 times 4 is 16, and 4 plus 4 plus 4 plus 4 is 16 as well. But, is there other values that would work, I wonder? Alright, so the way I would look at this is to say 16 can split up into either 2 and 8. But that doesn't work, because 2 plus 8 plus 2 plus 8 gives us more perimeter. 1 and 16 gives us too much perimeter. So the only other two factors are 4 and 4, which will give us this perimeter and that area. So that one was kind of some trial and error, but it still works, and that will do for now. So if we wanted the width on rectangle 4, the width of 2 is 4 plus 2, that's going to be 6 units. But if the area is 42, then we have 42 equals 6 times the length. So the length we'll figure out by dividing both sides by 6. And that is 7. So if that's 7 units, then to find the perimeter, we do 7 plus 6 plus 7 plus 6, which is 26 units. Not units squared, just units. All right, now that we have the length and widths, we are ready to graph these on these graphs. We are ready to start drawing our rectangles. So rectangle 1 up here in the top left, rectangle 1 is an 8 by 8. So let's go ahead and put that in. So 1, 2, 3, 4, 1, 2, 3, 4. I think I went too far. Alright, so this is 8 by 8, and we'll just finish this off to make our square. 8 by 8 for rectangle number 1. Rectangle 2 is a 4 by 4 square also, so let's go ahead and draw that in. Bam, there we go. Rectangle 3 is an 8 by 6, so let's draw that in. So there's an 8 right there, and by 6, 3, 6. We'll just finish off this rectangle as number 3. And then finally number 4 is a 7 by 6. So we'll make this 7, 3, 6, 7 by 3, 6, 7 by 6. And this is rectangle number 4. Alright, there's all of it. All the work that we did. It's a lot of work. It was good. List as many rectangles as you can that have an area of 36. We're not looking for any fractions or decimals on this. So, for example, I could have a 1 by 36 rectangle. I could also have a 2 by 18 rectangle. I could also have a 3 by 12 rectangle. Or a 4 by 9er. Maybe I wanted a 6 by 6 rectangle, which is also a square. But this is as many as we could list for whole values. Alright, it says to draw 2 parallelograms, but we've already drawn them for you, which is extremely generous. Let's go ahead and state the base and the height for both of these. So let's go ahead and label this. The base for the rectangle has a base of 3 and a height of, that's not 3. Thank you, that's 4. And the height is 3, that's better. Okay. This parallelogram has a base of 4, and its height, we're just looking at how tall it is, at a 90-degree angle, is 3 also. Now the reason why this is important is because, let's say this triangle right here, let's go ahead and cut it off, and then place it right here. Now what kind of shape does we have? Now it is a rectangle that is a 4 by 3 rectangle. So what this means is that parallelograms, we find the area the same way that we do rectangles, which are also types of parallelograms, okay? So what is the area of the rectangle? 12 units squared. And the area of the parallelogram? Also would have been 12 units squared. Before we do the next problem, we need to remember what the area of a triangle is. So the area of a triangle is when we take the base and we multiply it by the height, and then we divide all that garbage by 2. The reason why this should look familiar, by the way. Base times height is how we find what? The area for what shape? A rectangle. But by dividing it by 2, it's like cutting that rectangle through its diagonals, creating a new triangle. Let's go and draw 2 different triangles that have an area of 12. We're going to state the base and height. Alright, so we need 2 triangles that have an area of 12. So it really doesn't matter what it looks like. But the height of this thing is going to make a 90-degree angle with the base. So I'm going to say that this side length right here, that is the base. And the red line is the height. So, what I would want to know is, if I change this triangle and doubled it into a rectangle, what would be its area? I would need it to be 24. So, yeah, that's very good. You could have a base of 6 and a height of 4. Let's just check to make sure. So I've got my base of 6, my height of 4. Does this give me an area of 12?
Yes.
Sure does. If I put that in my calculator, it will give me 12. But that's only one triangle. So yeah, I'm going to do a right triangle next. I think that's a great idea. So, I'm going to do a right triangle up in here. And we're going to say that's 90 degrees. It's not perfect, but whatever. What could be the height of this right triangle? Let's not use 6 and 4 again.
8.
Let's say it's 12. If its height is 12, then the base must be 2. Now that's not drawn to scale, and that's alright. Well, let's just check to make sure this would work. So I'm going to divide it by 2, right? Multiply these. So I've got the base, which is 2, and the height is 12. This equals 12. That's good. And now we have two triangles that have an area of 12, and we've stated the base and height. Suppose you start with a rectangle that has a base length of 6 and a height of 4. Let's draw that up, Radical. So it's a base length of 6 and a height of 4. Base length of 6, something like these. If we triple the length of the base, what must we do to the height to have a new rectangle with the same area? Well, so if we triple the base and we triple the height, it's going to make this, it's just going to scale this to be a bigger scaled version of this. But we want to keep the area the same after we have tripled the base. These. That means that the new shape would have 6, 12, 18. So the whole shape has a base now of 18, tripled to 6. But the old area on a these was 4 times 6 is 24. So how do we maintain an area of 24 after we've tripled the base? Well, as it turns out, we would have to cut the 4 in thirds to maintain a area of 24. So that would be 4 thirds as the height now. So it would be a 4 thirds by 18. 4 thirds times 18 gives us an area of 24. That's what we want. So the actual answer for this is that you'd have to divide by 4. Not 4, but 3. You have to divide by 3. So if you triple one of the dimensions, you've got to cut the other one by the same amount so that you do not lose any area. Mike, Juliana, and Yo were working together on a garden area and perimeter problem their teacher gave them. The problem is to make the area of a garden larger without having to buy more fencing, increasing the perimeter. Their task is to figure out if that's possible. Mike say, we have to buy more fencing because if we increase the area of the garden, we will need more fencing to go around. Juliana say, that's not true, she says. We can use the same amount of fencing and move it to make the area of the garden larger. Joe disagreed with both Mike and Juliana. He say, I know a way that we can make the garden larger and use less fencing. Who is correct? If we look at what Mike says, do we need more fencing if we're going to increase the area?
Yes.
Increase the area? As it turns out, we does not.
What is that silver thing?
What about Juliana? She say that's not true, so she's correct in saying that's not true. But can they use the same amount of fencing and move it to make the area of the larger garden larger? Well, as it turns out, they can do that. They can increase the area by moving the fencing round, and that would make the area of the garden larger. We'll show that in here in a moment. Joe disagreed with both Mike and Juliana. He said, I know a way to make it larger and use less fencing. That may be true. So as it turns out, Juliana and Joe may be correct. It depends on what they're already looking at and how much fencing they have. So let's consider an example of these. So you guys remember making a rectangle with these, right? Let's go ahead and just consider what the perimeter and area is on these. So we're going to find the perimeter and also the area of all of this. So the perimeter of the 1 by 36 would be what? 1 plus 36 plus 1 plus 36. I get 74 perimeter. Well, what's the area? 36. What about a 2 by 18? What's the perimeter of these?
18, that would be 18 times 2.
So 2 plus 18 plus 2 plus 18. 40. Where the area is 36. What about the perimeter of 3 by 12? 3 plus 12 plus 3 plus 12? 30. What's happening to the perimeter as we go down this list, you guys? It's getting smaller, smaller. What about 4 by 9er? How much perimeter is there? 26, right? What's the area? 36. What about 6 by 6? How much perimeter would we have up in count? 24. How much area? 36. So do you guys see that we can decrease the perimeter, the amount of fencing we need, while maintaining the same area? So if we had the same amount of fencing, like 74 here at the top, could we rearrange the 74 perimeter to create more area? Certainly we could. Could we use less perimeter and create more area? Indeed. All we got to do is, what do you guys notice about these numbers as well as we get farther down the list?
Smaller.
They're getting smaller. What else?
There's less of a gap.
There's less of a gap, meaning we're getting closer and closer to what shape? Square. The closer you get to a square, you will maintain possibly the area, but you will be using less and less perimeter. So if you guys wanted to, right, the 1 by 36, bam, there we go, something like this. That'd be nice to put a dog in, right? Like, wow, we love this dog. It gets 36 square units of area, right? Whatever it is.
Yeah, but it only gets one thing.
Yeah, so they can run up and down. Hey, there you go, fetch this one, right? Well, if you wanted to, maybe perhaps that's more humane. Perhaps give them the same area, but give them a square, and then you're going to save your parents some money by building with less fencing. Or just tell them you want the fencing for 74, but then build the dog a 6 by 6 one. Don't be dishonest. Though.